we are going to see how to use the IDS Resynthesis. So we first choose IDS application folder, within it IDS Resynthesis SLEP subfolder, and within it we choose IDS Resynthesis SLEP application and launch it. It opens PD Extended, which is unfortunately a dead branch of the PD development. It's the one which works quite good with macOS 10.9.5 and macOS 10.10, and it's the 0.33.4 extended version. We have two windows, the PD main window and the IDS profiles window, where all the IDS profiles plots will be plotted. First, we've got to go to the default WEF file, which is in fact a patch, and we open it. And here we've got the definition of a default path, which is not good because it's not related to the same computer. So we have to get the right location. So we go to the Finder, go to the IDS Resynthesis data, within Data Lab, within Web Origin files, and choose, for instance, the first one, and get the information about this file. Here we've got the location, the needed location. I copy it, go back to Pure Data, and I switch to edition mode, and I change the key parameter here. Okay, if you want to use some personal web files, you can do exactly the same. That's to say, choose another path than the one which is defined by default here. We won't use this possibility. We must save the application in order to take into account our modification of the default path. Now if we click on the bank button related to default web files, we've got a modification here, which is the list of the name of the available web files. For instance, we choose first one, and if I stop it, we have listened some sound, which is the content of the subband number 7, which is from 1.8 to 3000 kilohertz. We have a stereophonic wave, so we've got two curves here, with the red one associated to the left channel. We have two mid-level in full scale dB and two columns. Here we've got 10 subband, as we've got 10 subband within the LEP frequency mapping. If we use the other resynthesizers, we will have from 11 to 13 subbands and 11 to 13 checkboxes. What can be done? It's selecting one subband and going from one subband to the other in order to see if there's something to listen. We only listen audio content with the third subband because we are using the loudspeaker, the internal loudspeaker of the computer, and there's quasi no sound level with under 200 Hz. So for the third one, fourth one, fifth, sixth, seventh, ninth, and 10. In the 10th, we do not listen to something because we are above 15 kHz and there's almost nothing within the original. And it depends also of the diffusion system and the capacities of the subject which is listening to this subband. So what can be done, for instance, is using the IDS profiles in order to resynthesize by adding this subband by subband in order to see what's going on. So we first use a second, and we are going to add third, fourth, and so on. Almost nothing for the moment. We add third one, fourth, fifth, sixth, seventh, eighth, ninth. And if we use the CK, we switch to the complementary subband selection. That's to say only subband 1 and 10, with almost nothing to listen. And we can also switch to the original either by clicking on this button or by using the O key. So another interesting test is to go from every subband and subtract subbands by subband in order to see which is a minimal selection of subband in order to have something which is rather close to the original. So we consider the selection of all the subbands. If we have adapt, we can switch to the complementary selection and listen that there's almost nothing. So we switch to the I do not select subband 1, and there is no sensible modification a priori. I go back to the complementary subband selection, and I suppress subband 2. Here, even if we got most of the energy for the right channel within the subband number 2, we cannot hear the difference because we are using the internal loudspeaker of the computer. So it may be rather different using a normal audio diffusion system, an external one. Okay, we go to the other selection, subband selection. And we see that here we have suppressed something which is rather used to the drums. We have a part of the saxophone and maybe the drum section. If I do not take into account subband 3 and 4, I've lost a major part of the low frequency content. So we can try to adjust the selection. In order to have something which is rather similar to the original. Okay. Need this one. If we switch from the selection to the original, we can notice that there's something needed in the higher register. So with selection from subband 3 to 9, with this computer we have something which is rather close to the original. That's for this example. We can also see at another one using electro music, for instance this one. Place to go. And This time we have something within the subband 2, so adding or subtracting it as a sensible effect. I haven't said it, but we can also choose to activate or deactivate the subband using the relative key. For instance, I activate subband 1 using the using the one typing 1 on my keyboard. The same for 2. I typed 2, 3, 4, 5, etc. Okay, so I need to at least one subband. So another thing which can be tested is something which is rather logic, that's to say adding, changing, switching from a selection to the complementary to the original. Yes, I'm going. Yes, I'm going. No place to go. No place to go. Darling, no place to go. And it will be really interesting to compare what happens according to the frequency mapping. With my students in sound engineering at Louis Lumière and at the Formation Supérieure Métier du Son, we have noticed that the LEP frequency seems much more interesting than, for instance, the octave or audio ones, because the decomposition of the spectrum is more adapted to the music or to the voice, for instance. In fact, it would be really rather interesting to test the 3 mappings available for the moment in order to see which is more adapted to your needs. And in the further, I will think about giving the user the opportunity to define his personal frequency mapping and or frequency mappings. And I've been working on the development and port of the tools in order to be able to determine the most interesting frequency mapping given a corpus of stimuli. So it's the end of the demonstration of the IDS Resynthetizers process using pure data. And as I've said before, the way the To Use Resynthetizers run is exactly the same as the IDS Resynthetizers LEP application.